understand it better. Supposedly two gears are there, and now why I'm drawing the diagram as irregular, because right now I don't know whether they are gear or not. Suppose Anjali, this is my first body. This is my first body and I'm drawing in this way. Okay, and there is an another body. That body is in this way. Suppose this is the body, and you can call it as this, in this way. This is the body number one. This is the body number two. Got it? If they are in
Yes.
contact, they are in contact with each other, and there is a perpendicular line. So I'm drawing a perpendicular over here. So this point is what, Anjali? This point is our Q. Okay, this point is Q, and the center of this point, this body is what, Anjali? O1, and center of the another body is known as O2. Okay,
Okay.
so the gear, whole gear try to rotate about point O2, and this gear try to rotate about 1. If they are bodies or gear, and later on it will be verified that these are not bodies, simply bodies, these are gears. Okay, O1 and O2. So there is this black line is known as usually what? Sliding line. This black
Okay.
line is what? Sliding line.
Sliding.
Okay, so there must be some linear velocity component and angular velocity component also. If this body is rotating, Anjali, this body is rotating in, you can say, anti-clockwise direction, having angular velocity omega 1, and this body is rotating in clockwise direction, and angular velocity is what, Anjali? Omega 2. Okay, so now I am drawing a line. I am drawing a line which is that line is known as line of action. So the line of action look like how? Line of action look like in this way, and this is how the line of action is there. In this line of action, the force F is present, actually. Okay, F force is present over here, and now what I am doing, that I am drawing perpendiculars on this line from O1 and O2. So let me draw the perpendicular, Anjali. This is the perpendicular, and this point is known as N, and this is the 90-degree angle, Anjali. Okay, and again I
Okay.
am drawing the perpendicular from O1 to on this line of action, and that point is known as, Anjali, M point. This is also perpendicular. Now the diagram, are you understanding this diagram? Na?
Yes, sir. Yes,
Slowly.
sir.
So now what I am doing, actually, I am joining the point Q to O1. Q to O1. Okay. So let me draw it with a straight line, na? So that it look like a triangle. Okay. So Q point is joined with O1. Okay. So let me make it red, na, so that you can clearly see itself what is the triangle you are talking about. That triangle, actually, QMO1. Okay, this triangle I'm going to discuss.
Okay.
Now again, I'm joining the Q to O2. Okay, actually, so these two triangles are having a lot of use to us. Okay, so there is an angle also, Anjali. There is an angle also. So this angle is known as, Anjali, what? Alpha. And this angle of this triangle is known as, Anjali, what? Beta. Alpha and beta.
Beta.
Okay. So always there is a velocity present, and that velocity component is always present. So that velocity component is V1 is was what, actually? R1 omega 1. Na? V2 is what? R2 omega 2,
Yes.
because we have denoted the omega 1 and omega 2, but now I need to show the linear velocity component also. So these alpha and beta angle are again denoted at point number Q, and that is a separate part, that is mathematics. You don't have any need to understand how these components are denoted. So there is a component, actually, that is known as what? V2, and that V2 component is equal to what, actually? O2Q into omega 2. This is radius, this is omega. Okay, this is for the body number
Okay.
2, and the angle is also present there, and that angle is what, actually, due to mathematics, this angle become our beta. Okay, and another component is also present. That component is over here. That is what? V1, and for V1, the radius is what? O1Q into omega 1. I will talk about this V1 and V2 later on, but for proper contact, what should be the condition? For proper contact between these two bodies, what should be the condition, Anjali? That V1 cos alpha must be equal to V2 cos beta. This is the condition for the proper contact between the two bodies. Okay, why? Because V1 and V2 component along the line of action cannot be same, na? Okay, V1 and V2 component along the line of action cannot be same. So that's why V1 cos alpha must be equal to V2 cos beta. Okay, and what is V1 cos alpha? V1 value I have already written over here, na? V1 value O1Q omega 1. Okay, O1Q and omega 1, and due to the with the help of triangle. Where is triangle, Anjali? Let me draw it again. This is the line, and here is this triangle, that is O1, sorry, O1 M, and that is point number, you can say, okay, that is N, that is our, sorry, I'm drawing again O2, and this is M, na? So angle is there, na? This is beta, and this angle is what? Alpha. Okay. So what is cos alpha, Anjali? Because this angle is 90 degree, na? This is cos alpha.
Yes, sir.
So cos alpha becomes what, Anjali? O1M by O1Q. Got it? This point is supposed as Q. O1M by O1Q is known as base upon hypotenuse cos alpha. So similarly, V2 becomes what? O2Q and omega 2. And what is our cos beta? O2N by O2Q. Okay. So O1Q and O2Qs are cancelled with each other. O1Q and O2Qs are exactly equal to each other. Why they are equal to each other? Because later on I will prove that this point Q is not Q point. This is the pitch point P. Okay, and see, O1Q is cancelled by this point, Anjali. Actually, O1Q is cancelled by this O1Q, and O2Q is cancelled by this O2Q. Okay, so the omega 1 by omega 2, omega 1 by omega 2 comes out to be, Anjali, O2N by O1M. Okay, and from this similar triangle, Anjali, from this similar triangle, we can see that O2N, see, O2N and O1M, these are the perpendicular, na, Anjali, and that is equal to, suppose a point is there is a point, Anjali, suppose here is a point that is known as pitch point P, and later on I will prove that this pitch point will exactly lie at the point number Q. Later on I will prove that. So suppose that point is not Q, that point is suppose P. So O2N by O1M is equal to O2P O1P, and later on PN and PM. Similar triangle basically I have proved, na? Because see, this is the triangle, na? This is the triangle, this is O1, this is O2, this is N, this is M and P. Now you can clearly see that O2N O1M. Okay, O2N O1M perpendicular, O2P, okay, hypotenuse, and O1P, okay, and NP and PM. All three, the three sides ratio have been taken, na, Anjali? But what is the value of this triangle similarity and all that? The value of this triangle means that the value of this ratio means that if these two bodies are gear, then it is very clear that omega by omega 2 must be constant, na? This is the condition for the bodies to be gears. So the body for body to be gears, then O2P ratio and O1P ratio must be constant, actually. That ratio must be constant, because omega 1 by omega 2 is also equal to this ratio also, na? So O2P and O1P, actually, see, this O2P and O1P, this ratio should be equal, or you can say this length ratio should be equal, and I can say that O1 and O2 point is already fixed, na Anjali? O1 and O2 point is already fixed point because they are the
Yes,
center
sir.
of the bodies. Okay,
Yes,
so
yes, sir.
which came to the conclusion that the point P is also a fixed point. P is a fixed point. If this point P is not fixed, then we cannot say that O2P and O1P ratio is constant. Then the bodies could not be called as a pitch point. So here comes the statement of the law of gearing, which says that line of action, Anjali, line of action must always pass through the fixed point
Okay.
on the line joining the center of rotation of
Okay.
gears. This is the statement, na? Line of action must always pass through the fixed point P. That is the pitch point, na? And the line joining the center of rotation of gears. So the statement says that this pitch point is a fixed point, and on the line joining the center of O1 and O2, there is always point P is present, and that line of action is this PM point. So the pitch point P lies on the intersection of the center of two bodies and the line of action intersecting point. And that pitch point is the fixed point. Whenever two pitch circle try to rotate, this pitch point is not changing its position. This is the law of gearing.
Okay.
So for the bodies to be gear, I am giving you a condition for the bodies to be called as gear. To be called as gear. What is the condition actually? The condition is that line of action must means 100%, must always pass through pitch point P. Okay, first condition, and that line of action is the common normal to Q point. Okay, so I am coming to the diagram. I am coming to my diagram. That pitch point is shifting over Q point. Then and then only this thing could be possible. And this is the statement of gear. So I can say that actually the mating profile of the gear must be designed in such a way that the law of gearing is always satisfied. Law of gearing is always satisfied. That is why the profile becomes so much important. If the pitch point is unstable, then the gear cannot touch with each other, because pitch circle, the common point where the pitch circle are touching is the pitch point P, na Anjali? If the pitch point is moving away here and there, then we cannot say that the gears are meshing. Okay, so for mating profile must be designed in such a way that there is always law of gearing satisfaction. Okay, so two kinds of gear teeth profiles are there, Anjali. Two kinds of gear teeth profiles are there. First one is what, Anjali? Involute profile. Have you heard about it, Anjali? Involute profile.
Yes, sir.
And another one is cycloidal. Heard about it or not? Cycloidal profile.
Yes, sir.
And both profile are very, very important as soon as. So there is a small thing as also there. Let me tell you this thing first. And tomorrow or in upcoming lecture, whenever you will get time, we will do the profile of gear teeth and some one or two formulas, and based upon that we will do the numerical in the upcoming class. So the velocity of sliding is there, Anjali. Velocity of sliding is also there. What is the formula of velocity of sliding? V sliding. V sliding formula is what, Anjali? Is equal to V1 sine alpha minus V2 sine beta. Okay, and after the you can say small derivation, and that derivation is, there is no any use of it, because I am putting the V1 is equal to R1 omega 1 sine alpha value, and after the little calculation, that velocity of sliding formula which you need to remember, because every time the examiner used to ask. That is very simple only. Omega 1 plus omega 2, and that distance he used to provide. QP distance he used to provide us. Okay, so and that QP
Okay.
distance is known as what? Path of approach. In the numerical, we will say that calculate the path of approach.
Okay.
With the help of formula, we will calculate the path of approach, and he will provide the RPM. So 2 pi n1 by 60, that becomes omega 1. 2 pi n2 by 60, that become omega 2. And path of approach has a separate formula, and QP value is multiplied by omega 1 plus omega 2. That is how the velocity of sliding is being calculated. Okay, so you